Hey there everyone, welcome to the first day of our lesson of section 10.2, which is about arithmetic sequences. As you can see here, first we have a 4-problem warm-up from things that we should already have learned in this chapter. So what I'd like you to do here is just pause the video for as long as you need to, work on this warm-up, and once you have completed all 4 problems, you can unpause the video to check your answers. Okay, here are the answers to the warm-up problems. You can see for part A, just writing the 4 terms out from that sequence by putting in 1, 2, 3, and 4 in for n. For B, the next term would be 3 over 32, and any term in this sequence would be 3 divided by 2 to the nth power. For C, you can see we're just counting up by 3 here, so 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 3, so forth and so on. So the nth term is 3n, and we're going to go from 1 to 25. And for D, putting in 1, 2, 3, and 4 into that expression yields 3, 12, 27, and 48. Add those together, you get 87. All right, on to the new stuff for today. Today we're going to talk about a special kind of sequence called an arithmetic sequence. Arithmetic are special because each term in between is a constant difference, where we either add or subtract a number, or we can even say we add a positive or negative number the same time over and over and over again. Okay? That number could be 3 or 7 or negative 5 or whatever, but it has to be the same number over and over and over again. So the question is asking us, are these arithmetic or not? If they are, what is the common difference? Very easy way to check. To go from 5 to 11, we add 6. To go from 11 to 17, we add 6. Add 6. Add 6. We're adding the same number every time. So this is arithmetic. And our common difference is positive 6. For part B, we add 6, and then we add 18. You can stop right there. We're already not adding the same number every time. So this is not arithmetic. Okay, there is another type of sequence that we'll learn next week that this one might be. Letter C, we add 4, and then we add 4, and then we add 2. Okay, well, that's different, so we can stop there. This one is also not arithmetic. And D, we subtract 8, and then subtract 8, and then subtract 8, and one more time subtract 8. So this time we are doing the same thing every time. We're adding negative 8 each time. So this one is arithmetic, and our common difference is negative 8. So the nice thing about the arithmetic sequences, if you look back at the warm-up here, like for example in part C, when I ask you to write an explicit equation out, an explicit formula out for a sequence, if you recognize that it's arithmetic, there's a special formula you can use every time, and it works every time. So this is called the explicit rule or the explicit formula, or again, it could be called the general rule or general formula for an arithmetic sequence. The nth term of an arithmetic sequence with first term a sub 1 and common difference d is given by the formula a sub n equals a sub 1, the first term, plus n minus 1 times d, the common difference. So let's see how this works. Example 1 says to write the explicit formula for the nth term of this sequence, then find a sub 12. So the first thing you need to do is figure out if this is arithmetic or not. Add 15, add 15, add 15. This is arithmetic. That's great news. The common difference is 15. So now we can just go right to our formula here. A sub n equals the first term, which is 32, plus n minus 1 times the common difference. And that's it. That's our formula. Now I am going to ask you that we simplify this a little bit here. So a sub n equals 32 plus 15n minus 15, or a sub n equals 17 plus 15n. This is the nth term, or the explicit rule for this sequence. Okay? And now it says to find a sub 12. Well, now we got our explicit formula. This is going to be a piece of cake. A sub 12 equals 17 plus 15 times 12. Right? And that's 17 plus, let's see, 15 times 12 would be 180. So 17 plus 180. Our 12th term is 197. Example 2, one term of an arithmetic sequence is a sub 8 equals 50. The common difference is 2. Write an explicit rule. Okay. So let's just copy down our formula here so we can see where everything goes. Okay, so it says a sub 8 is 50. So that's going to go in here for a sub n. We don't know what the first term is. We know that when a sub 8 is 50, that means that n is 8. It's the 8th term. And the common difference is 2. So it looks like all we got to do is find a sub 1. And our first term is 36. So now we have our first term. We have our common difference. We can write our formula out. A sub n equals a sub 1 plus n minus 1 times the common difference. Okay, once again, I would ask you to simplify this a little bit here. So a sub n equals 36 plus 2n minus 2. Or a sub n equals 34 plus 2n. Example 3, two terms of an arithmetic sequence are a sub 5 equals 10 and a sub 10 equals 110. Write an explicit rule for the term, and then find the value of n for which a sub n equals 70. All right, there's a lot going on here to unpack. Let's just start with the same formula we had before. We know a sub 5 equals 10. All right, so 10 equals a sub 1 plus 5 minus 1 times d. We don't know what a sub 1 is, and we don't know what the difference is. We also know a sub 10 equals 110. So 110 equals a sub 1 plus 10 minus 1 times d. It may not look like it, but this is a system of equations. All right, let's do a little simplifying here. So we get 10 equals a sub 1 plus 4d. And then we have 110 equals a sub 1 plus 9d. So how would we solve a system? Well, you can do either substitution or elimination. It's a very easy one to eliminate. So let's just multiply this by negative 1. And we get, when we add together, we get 100. A sub 1's cancel. And then 9d minus 4d is 5d. Dividing both sides by 5 now, we know that d is 20. All right, now you can take that 20 and put it back into either one of these two equations. It doesn't matter which one. So maybe I'll use the top one. I get 10 equals a sub 1 plus 4 times 20, which is 10 equals a sub 1 plus 80. which then means negative 70 is a sub 1. All right, we got our first term and we got our common difference. Let's write out our nth term. So a sub n equals negative 70 plus n minus 1 times 20. All right, if you want to simplify that, you can, but we don't need to because the question's asking us to find the next part, which is when, for what n is a sub n equals 70. All right, so you don't need to simplify this. I always do, just because I think it's easier to work with. So let's simplify this a little bit here. So we get negative 90 plus 20n. All right, now we can go back and answer that second part of the question. A sub n equals 70, and we want to know what is n equal to. All right, well, let's put 70 in for a sub n. We're going to put 70 in for a sub n here. And solve for n by adding 90 and dividing by 20. So 70 is the 8th term in this sequence. Sorry for the work all over the place here. Okay, example 4, find the 500th term of this sequence. Well, in order to do that, there's two ways we can do it. We can literally count 500 times through this, or we can just find the nth term. Even though the question doesn't tell us to, that's probably the better idea to do. As we can see here, we are adding 5 each time. So that means our common difference is 5, and this is an arithmetic sequence. So the nth term would be negative 4 plus n minus 1 times 5. Again, for this one, we don't need to simplify this because we're trying to find the 500th term, but I always like to do it anyway. So 5n minus 9 is our nth term. And now we can very easily find the 500th term. So 5 times 500 minus 9, that would be 2,500 minus 9, which is 2491. Last one here. Tommy earned $50,000 in his first year at his job. He gets regular raises on a yearly basis. His second year, he earned $50,700. In his third year, he earned $51,400. How much will he earn in his 25th year? So again, you want to recognize, is this arithmetic or not? And the answer is yes. Our common difference is $700. He's getting $700 raises, which really is not that good. So he must not be doing a very good job. But that's okay. Let's figure out what he would earn in his 25th year anyway. So our nth term would be 50,000 plus n minus 1 times 700. And if we simplify that, we get 49,300 plus 700n is my nth term. Okay, my explicit formula for that. But that's not what the question's asking for. The question's asking for how much will he earn in his 25th year. But now that we have our nth term, this is going to be really easy for us to do. We're going to put 25 in here. Okay, and I'm not going to expect you to be able to do that without a calculator. So you can pull out a calculator for this one if you need to. We can do 700 times 25 and add that to 49,300. And after 25 years of service, Tommy's going to be making $66,800, which really isn't great after 25 years. So Tommy better start working harder or find a new job. That'll do it for our first part of section 10.1, which is about arithmetic sequences. We'll learn a little bit more about arithmetic sequences next time, how to find the sums of them, and then we'll do some practice after that. Thanks for tuning in today.